AI has gone from potential to actually valuable. How do we get more out of the data we've already collected?
AI is not going to magically solve climate change. It's not going to magically solve sustainability challenges.
AI can be superhuman, but ultimately it is up to us to make the key decisions.
I really hope that by 2050, we have a much better understanding of what action we're going to take and how that action will play out across many different lenses that we care about.
Welcome to the Schmidt Sciences AI 2050 Roundtable on Climate, Sustainability, and AI. I'm Swathi Pandey. I'm with Schmidt Sciences, and I'm joined by you wonderful fellows of the AI 2050 program. To start things off, I'd love to get a sense from everyone about where we currently stand and how AI is being used in climate and sustainability.
One of the things I'm really excited to see, and it has just been such an amazing thing to witness in my career, is AI going from not working to working. So, when I first started working in computer vision, my very first research project in undergrad, we were trying to identify individual snow leopards with computer vision. We had an entirely complicated, handcrafted, feature-engineered system that worked okay in very specific scenarios when you had really perfect quality data, and just was incredibly brittle and would constantly fail when actually deployed. And it's been about 13 years since then, and I've sort of been a part of and witnessed these developments in AI that have gone from something that was more of a theoretical construct to actually something that is deployed. So, for example, there are hundreds of thousands of deployed camera traps that are studying wildlife around the world. These cameras are placed out in remote areas. They can collect millions of images in a season. We have a model that just filters out what is interesting data from what's not interesting data, just does a really good job of detecting humans, animals, vehicles. That thing is robust, and it's useful, and it gets used. And that's been so exciting for me to see. Just like that AI has gone from potential to actually valuable. But then where it gets messy is like beyond doing easy stuff fast. Like, how do we actually get to the point where we build systems as effective as experts, expert taxonomists, expert sort of ecologists, environmental scientists who have this deep understanding, these hard-won priors about the world and can actually sort of effectively reason about it and generalize well. And I think that's probably why all of us still have jobs, right? Because there's a lot still to do.
So there are a lot of people who hope that AI is just going to solve the climate crisis for us. What do you think, what role will AI play, and what role do humans need to play?
AI is being used to lower power consumption in factories, in the heating and cooling systems in buildings. AI is being used to help people who want to make decisions about land use in sustainable ways make those decisions in a more informed way. But AI is not going to magically solve climate change. It's not going to magically solve sustainability challenges. AI is one tool among many that give us greater ability to act, can reduce some of the barriers to action, but don't make the decisions for us as a society. There are tough decisions that need to be made by people around the world, and there are a lot of other tools that are needed in order to make those decisions effectively as well. We need the policymakers, we need the lawyers, we need the artists, we need the writers, we need everybody to be thinking about how their skills can be relevant in tackling these challenges. And so if you are listening and you have other skills that you would like to devote to climate and sustainability, we need you, because it's all hands on deck.
Great answer. I fully agree. I think that AI can be a formidable player, and it should be a formidable player. And actually, I think AI can be superhuman in many aspects. But ultimately, it is up to us to make the key decisions. It is up to us to define the goals, to define the constraints, to define the thresholds that we want to operate on.
I'd love to dive into everyone's work a little bit more specifically if we could. Carla, can you just explain what computational sustainability is for those who might not have heard the phrase before, the non-scientists?
So the computational sustainability aims to develop computational and AI methods to tackle sustainability challenges. And a key point that I have emphasized is that computational sustainability is not just about climate, or it's not just about the environment, but really brings together and aims to balance environmental, economic, and societal issues. By actually tackling these problems, we interact with domain scientists, experts, and we actually learn new concepts, new ideas that can actually transform our own approaches. So a good example of a computational sustainability problem is the problem of predicting how species are distributed across landscape and over time. It's very important to know how birds or other species are distributed, because we want to pass that information to conservation NGOs and government institutions for conservation actions. In order to tackle this problem, we need to fully understand how species interact with the environment and how they interact with each other. Typically, existing deep learning models do not capture interactions. By using ecological principles, we were able to develop models that are fundamentally different from the standard models. And what's more exciting is, because we developed these models and we understood the importance of having an interpretable latent space, we could then transfer these insights to predict abundance for fish, models to predict properties of materials, and including models to understand the crystal structures of materials, because we develop insights based on insights that we gain from bird distributions.
Sara, you focus on building AI systems, specifically AI agents, that can help people make sense of massive data sets. Can you tell us more about your work and how your research is helping monitor biodiversity and how it might help us mitigate that loss?
I really have thought for a long time about, what is the information that we need to be able to understand these incredibly complex systems. One of the things that makes this just so challenging is that biodiversity data is not comprehensive. The data itself is difficult to collect. It tends to be expensive. It's hard won. If you have to hike out into the remote Amazon to collect a data point, this is not the same as scraping something from the internet. And I've recently been obsessed with this question of if we need to scale the data we have about life on Earth, how do we get more out of the data we've already collected? Because we've actually collected huge amounts of data. Everything from, pretty wall-to-wall coverage with satellite and even high-resolution aerial imagery, but then down to, camera trap data on the ground. All of these data sets are complementary, and I think there's so much potential in just figuring out how to connect the dots between them. And so one very specific project that I'm really excited about and is really the sort of underpinning of my AI 2050 project is working with an organization called iNaturalist. It's another citizen science application where people, anyone, you guys, can go out and take pictures of plants and animals and insects. These get identified to species by the community, and then they become research-grade species observations in the Global Biodiversity Information Facility. So you're directly contributing to science. But the thing is, every single one of these pictures now has been labeled with a species. And so we have this information bottleneck. The only information we're keeping is just the presence of a single species. But every image has so much more scientific value than just the single species that has been labeled, right? We have these explicit interactions between species. We see behavior within a species. You see how species interact with specific plants. You can look at things like environmental factors in the background. You can measure the health and the morphology of trees. There's so much information that's just being left on the table. And there's 290 million images of species that are publicly available in iNaturalist. And so what we've been doing is working on multimodal AI systems that help experts, ecologists across disciplines, really quickly interact with this enormous database to be able to ask new questions, new scientific questions that would historically potentially have been incredibly expensive to even start to try to tackle. So one example of this, we've been partnering with researchers interested in looking at the way that bird diets change across seasons. So basically, what are birds eating during different times of the year? And how is that different for different species and in different cities in different parts of the world? And so what we've done is we've built these systems where ecologists can search across all of the images very efficiently and then find relevant matches to that search. You can search things like American robin eating insects. Find those, export them. American robin eating seeds. Find those, export them. You're just basically just this really efficient data curation process. So then this begs the question, how does the information that we are able to curate and analyze and develop actually change or inform the decisions we make about managing ecosystem stability? If you understand sort of the connections between sort of the diets of different species over time, then you can start to understand the risks to that food web. And then we can take our sort of set of tools in terms of ecosystem action, right? Management techniques. Do you try to explicitly help increase the breeding or the regeneration of a species? Do you need to think about targeted management, where maybe there's specific times of year where a given species is really at risk in terms of its food source, and so now you need to actually put in extra effort to protect it? It gives us this sense of targeted precision ecosystem management.
So as we talk about AI's role in climate solutions, one challenge is making sure that we can reach the people and places that need the most urgent action. So David, tell me a little bit about your AI 2050 project and how it addresses this data gap between regions.
One of the areas that we work on in my group is climate and weather modeling. And maybe just start out with some definitions. Climate is like long-term weather. Weather is what happens at like days and weeks, and climate is what happens at the scale of years or decades. And both weather and climate are modeled very effectively by Earth scientists using these complicated sets of physical models. Even though we know the physics of the climate and weather very well, it can take months, sometimes even a year, to run one of these big climate models to take all the factors into account. The data these models are based on is also really imperfect and often very skewed towards the regions that have the resources to put out good sensory systems. So famously, a lot of data is really bad in the global south, not because global south researchers are worse at gathering data, but because there aren't enough sensory stations. And the resources to create these sensory observations are lower in many places. So with these kinds of challenges, we're looking at ways to use AI to step in to not just speed up the simulation process, but also help account for some of the biases in data availability, sensory data availability. The other part, which is what we focus on in our AI 2050 work, is looking at the problem of super resolution. And super resolution is what happens when you see in a movie somebody says, enhance that image. And you get a sharper image that zooms in on exactly what you want. And in the climate and weather system, you can do that too. If you have only data at a really broad, coarse resolution, you need to develop computer vision algorithms that can go from blurry images to sharp images. And we've got those to some extent with images of people, because people have been working on that for years, but those same algorithms don't work for weather and climate data because clouds look different from people. And turns out that the same algorithms don't work, so you need to integrate physical laws. And then specifically, we're looking at data biases and how to have these models perform well across different geographic domains.
Bringing it back to what's achievable by 2050. Tell me your hopes for that year and what you think how will AI have helped us in terms of sustainability and climate?
I really hope that by 2050, we have a much better understanding of what action we're going to take and how that action will play out across many different lenses that we care about. I personally care a lot about biodiversity, but I also care about the sustainability of the human species and sort of the equity of access to a solid, a pleasant and sort of not painful life for the humans on Earth.
I think if we're looking at the horizon of 2050, the kinds of change that I would want to see need to happen far before that point. And the time before 2050 should be scaling them up and seeing their impacts bear fruit rather than looking to technology of 10 or 20 years down the road to save us.
Mm-hmm. Another area that I think would be critical is moving beyond AI for prediction. We actually need AI models that can suggest interventions. That is fundamentally harder. But, for example, we would like AI models who would give suggestions on how to operate the smart grid. If all of a sudden we have an outage, how do we rebalance, demand and supply? But I think we are making incredible progress where indeed we have good predictive models, but now we need good generative models to suggest interventions. It's not that I'm expecting the AI is going to make all the decisions. There are key decisions that should be left to the humans.
David, Sara, Carla, thank you so much for joining us.
Thank you for having us.
Thank you for having us.